everyone, back to basic electronics video. This is Manoj from Tenet Technetronics. In this video I am going to explain about the keypad matrix and demo on interfacing the same with the controller. For the demo I have taken an 4x4 keypad matrix. The specialty of the keypad matrix is the design uses the membrane switches as the keys, and the individual rows and the columns are extended through burr connectors that you can see it in the back side of the keypad. And this keypad also has a screw holes for easy installations. Tenet Technetronics takes order for these kind of custom-made keypads. The keypad features in terms of this arrangement of switches and the color combination of these membrane switches and the keypad and the size of the membrane switches can be custom engineered based on the customer requirement. Let's take a look at the physical arrangement of these keypad matrix. You can see these keys are located at the crossing between the matrix rows and the matrix columns. Normally these switches comes with two legs. One leg is connected to the common column and one leg is connected to the common rows. And these rows and the columns are extended to the burr connections, and those connections can be connected to any digital circuits or color controller circuits. Let's see to the working logic of this keypad matrix. In the working logic, consider a switch connected to this single row and a single column. Now the switch is in the open state. I am supplying normal VCC to the column and normal ground to this row. Coming to the second case here, if I press the switch, the connection is established between the row and the column. For the safer side, not to get shorted with the VCC and ground, I am connecting the resistor at the column side. Same thing considering the 2x2 matrix. Here the 4 switches are connected to the individual rows and individual columns. 1, 2, 3, 4, and I am connecting the two LEDs, LED 1 and LED 2 in series with column 1 and the row 1, and supplying a normal VCC to the column 1 and a ground to the row 1. Consider if I press the switch. Since I am providing a VCC to the column 1 and the ground to the row 1, the connection is established between the entire row 1 and the entire column 1. Since I am connecting the LED 1 in series with the column 1, the connection is closed, that is plus VCC and minus it is received from this end, and this LED starts lighting. Similarly, in case of LED 2, the positive supply is coming from the VCC and the ground here. Since the switch is closed, these LEDs also close. Now the conclusion is, whichever the switch pressed in the keypad matrix, say for if I press this key, whatever the supply present here and here is received through that particular row and particular column. The logic for checking which key is pressed is simple. You need to make the row lines low one by one and read the columns. Say for example, make R1 equal to 0, keep reading the columns. Say if I press this switch 2, what happens if I press this 2, columns 2 will go logic low. Then we come to know that key 2 of R1 is pressed. Let's look at the demo. Here I have interfaced the same keypad to the Arduino and the coded to print the keys pressed on the keypad in the serial monitor. Here I am pressing some keys. 1, 2, 3, and you can see the same thing in the serial monitor. Thank you for watching this video. If you have any related queries, please drop us a mail at info@tenet.techno. Thank you.